Hi everyone, I'll be going to the data analysis section of the 2019 multiple choice exam for further maths. Question 1. The histogram below shows the distribution size of 48 countries in 2018. The number of these countries with a population size between 5 million and 20 million people is. So we're going to find the number of countries with a population size between 5 million and 20 million. Population size has been plotted on the x-axis over here. So we're going to find the number of countries with a population size between 5 million and 20 million. So 5 million is over here, and 20 million is over here. So we've got to add these bars together. So that's 11, that's 4, that's 2. So 11 plus 4 plus 2 will give you the number of countries with a population size between 5 million and 20 million people. So put that on your calculator, or just put it in your head. So put that on your calculator, it'll give you 17. Therefore, B is the correct answer. Question 2. The shape of this histogram is best described as... So let's refer to question number 1, the histogram over here. So definitely the histogram is positively skewed, as we can see over here. It's positively skewed. And now we have to determine... So instantly we could get rid of these 3 options over here, because we know it has to be positively skewed, the histogram. Now I have to determine whether there are outliers or not. So we can see over here that this value is most likely, very, very highly likely to be an outlier. Same as these values, which could also be outliers. So therefore, B is the correct answer, as the shape of the histogram is positively skewed with outliers. Question 3. The histogram below shows the population size for these 48 countries plotted on a log 10 scale. Based on the histogram, the number of countries with a population size that is less than 100,000 people is. So we have to be very careful here. The question says that this histogram is plotted on a log 10 scale. So that means the values over here are 10 to the power of whatever value it is. So you just write 10 below all the values over here. So you're aware that this is a log 10 scale. And the question says the number of countries with a population size that is less than 100,000 people. So less than 100,000 people is 10 to the power of 5. So therefore 10 to the power of 5 is over here. So you want to find the number of countries with a population size that is less than 100,000. So basically we add this bar over here and this bar over here. It'll give us 7 and 1. So 7 plus 1 equals 8. So therefore 8 countries have a population size less than 100,000 people. Therefore, D is the correct answer. Question 4. The STEM plot below shows the distribution of mathematics test scores for a class of 23 students. For this class, the range of test scores is... So I've written over here the formula for the range. So the range is just the largest value minus the smallest value. So the largest value over here is 89, and the smallest value is 40. So therefore we just do 89 minus 40, which gives us 49. So therefore the range is 49. So therefore D is the correct answer. Question 5. For this class, the interquartile range of test scores is... So to do this, we're going to find the median value first of the distribution. The stem and leaf plot. So to do this, we do the value of the mean is m plus 1 divided by 2, where the value of n is 23 over here. So 23 plus 1 divided by 2 is 12. So you count 12 from the lowest number, gives you 68 over here. Then to find the interquartile Q1 and Q3, so we'll find Q1. To do this, Q1, we know Q1 is going to be in the first part before the mean. So to do this, you basically just got to find the mean of that section. So you count these values over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the value of the Q1 for this Q1 is 11 plus 1 divided by 2, which is 6. So you count 6 from the start over here, which is 1, 2, 3, 4, 5, 6. So therefore 57 is Q1. So to find Q3, you do the same thing for this section. If you add this up, it'll be 1 plus 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, 11. 11 plus 1 divided by 2 equals 6. So you count 6 from after the median, which is 1, 2, 3, 4, 5, 6. So therefore 75 is Q3. So now we just got to plug the values of Q3 and Q1 into the interquartile range formula. So 75 minus 57. Put that on your calculator, which is equal to 18. So therefore C is the correct answer. Question 6. The time taken to travel between two regional cities is approximately normally distributed with a mean of 70 minutes and a standard deviation of 2 minutes. The percentage of travel times that are between 66 minutes and 72 minutes is closest to. So to do this, you have to have the normal distribution somewhere in your notes, or at least know it. So in the question, we know that the mean is 70, so I've written 70 under the mean value over here. And the standard deviation is 2 minutes. So basically just this normal distribution shows the percentages in each standard deviation above or below the mean. So if we have the mean is 70 and the standard deviation is 2, so one standard deviation is above the mean is 72, two standard deviations above the mean 74, three standard deviations above the mean is 76. Now if we go below the mean, we're minusing 2 from the mean. So if we go below the mean, we're minusing 2 from the mean. So one standard deviation below the mean is 68. Two standard deviations below the mean, 66. Three standard deviations below the mean, 64. You notice that the difference between each standard deviation in the curve is 2 because the standard deviation given in the question is 2 minutes. So we have to find the percentage of travel times between 66 minutes over here, and 72 minutes over here. So if you look at the percentages, 66 minutes is here, between 66 minutes to 70 is between here, here, and here. So you just add these percentages on your calculator. You do 13.5% plus 34% plus 34% gives you 81.5%. Therefore, D is the correct answer. Question 7. The volume of a cup of soup served by machine is normally distributed with a mean of 240 milliliters and a standard deviation of 5 milliliters. A fast food store uses this machine to serve 160 cups of soup. The number of these cups of soup that are expected to contain less than 230 milliliters of soup is closest to. So we know the mean is 240 milliliters and the standard deviation is 5 milliliters. So we'll put 240 milliliters under the mean. We have to find how many cups of soup are expected to contain less than 230 milliliters. So we know that one standard deviation below the mean is 235 milliliters, because we're doing 240 minus 5, the standard deviation, to get 235, which is one standard deviation below the mean. If we want two standard deviations below the mean, it'll be 230. We just did 235 minus another 5 gives us 230. So we have found that two standard deviations below the mean is 230 milliliters. Now we need to find the number of cups of soup that are expected to contain less than 230 milliliters. So we know that 2.5% of the cups, as shown in the normal distribution over here, will be less than 230 milliliters. So we do 2.5 on 100 times 160 cups of soup, because the fast food store used the machine to serve 160 cups of soup. Put that on your calculator, you'll get 4. So therefore B is the correct answer. Question 8. Piercy conducted a survey of people in his workplace. He constructed a two-way frequency table involving two variables. One of the variables was attitude towards working days, for or against. The other variable could have been. So basically, I've just written over here, a two-way frequency table always has two categorical variables. You should have that somewhere in your notes, that a frequency table will always have two categorical variables. So the first categorical variable was attitude towards working days for or against. So we got to look for the other categorical variable. So age and years is obviously not a categorical variable. Sex, male or female, yeah, that's a categorical variable. So therefore B is correct answer, but just check the other ones in case. Height, that's obviously numerical. Income to the nearest $1,000, it's numerical as well. Time spent travelling to work in minutes is numerical, so therefore B is the correct answer. Question 9. A least squares line is used to model the relationship between the monthly average temperature and latitude recorded at 7 different weather stations. The equation of the least squares line is found to be, as given here. When the numbers in this equation are correctly rounded to 3 significant figures, the equation will be. So basically we just got to round the y-intercept and the slope to 3 significant figures. So if we do that for the y-intercept, it will be 42 point. It'll become 43.0 because this 8 over here rounds that in total to 43.0, and you must write the 0 because the 0 is significant. And then for the slope, 3 significant figures would be negative 0.877. The significant figure starts from here. The 0 over here is not considered a significant figure. So therefore, just look at the options you have. 43.0, negative 8.77, so therefore E is correct. Question 10. The coefficient of the determination was calculated to be 0.893743. The value of the correlation coefficient rounded to 3 decimal places is. So to do this, so the coefficient of determination is the r squared value over here. The value of the correlation coefficient is r. So to do this, the correlation coefficient could be either positive or negative. And to find out whether it's positive or negative, this depends on what the value of the slope is. So the slope from the question over here is negative. So if the slope is negative, therefore the correlation coefficient will be negative. However, if the slope was positive, the value of the correlation coefficient would be positive as well. However, in this case, we've got a negative slope, therefore the correlation coefficient is negative. So we just do negative square root 0.893743. Put that on your calculator, you'll get negative 0.945 rounded to 3 decimal places. So therefore A is the correct answer. Question 11. A study was conducted to investigate the effect of drinking coffee on sleep. In the study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day were recorded for a group of adults. The following summary statistics were generated. On average, for each additional cup of coffee drunk, the amount of sleep is. So, to do this question, we need to first determine which variable is the explanatory variable and which is the response variable. So, from this statement over here, we know that the number of for each additional coffee drunk, that's going to be x, the explanatory variable, and the amount of sleep is going to be y, the response variable. This is because the amount of sleep is what we're measuring, so therefore it's going to be the response variable. So therefore we just put y and x on here. So we know number of coffee cups is our x variable, and the number of sleep in hours is our y variable. So I've just written the formula for the slope over here, and basically this is what we need to do to solve the question. So b is just representative of the slope. So b equals r, so r over here is negative 0.77, so negative 0.77 times standard deviation of y. We've determined that the sleep is a y variable, so therefore standard deviation of y is 1.12. On the standard deviation of x, which is for the coffee cups, which is 1.56. Put that on your calculator, and you should get b equals negative 0.55 to 2 decimal places. So basically what this slope represents is that for every additional cup of coffee drunk, the amount of sleep will decrease, because the slope is negative over here as we can see, will decrease by 0.55 hours. So therefore A is the correct answer. Question 12. The table below shows the values of 2 variables, x and y. The associated scatter plot is also shown. The explanatory variable is x. The scatter plot is non-linear. A square transformation is applied to the variable x, so that would become x squared once the square transformation is applied. This can be used to linearize the scatter plot. The equation of the least squares line fitted to the linearized data is closest to So basically, to this question, you have to enter the values of x and y. Open a spreadsheet up, then enter the values of x and y in 2 columns. So you label the first column x and the second column y. Enter the values of x in the first column and y. Enter the values of y under the y column. And once you've done that, you can find the x squared values by just writing another variable. I can write x squared on my calculator. I just write xs, which stands for x squared. And I go down and I'll hit menu. And I hit I'll hit x squared. So basically we're squaring the x values. Press enter. It says column or variable reference. Hit variable reference. Then press OK. And it has the x squared values over there. So now we just have to find the equation of the least squares line fitted to the linearized data. So basically, go into one of the second rows in the spreadsheet and hit menu for 4 to find the least squares regression line. Put the value of x in. We want x squared because we've been told we want the equation of the least squares line fitted to the linearized data. So x squared would make the data linearized. So we've got xs here, which stands for x squared. Hit that, put that in the x list. Then just put y in the y list. So y. Hit enter. And you have the values of a and b over here. So y equals the value of a is negative 1.34 rounded to 2 decimal places, plus the value of b. B is 0.54, 546 to 3 decimal places, 546 x squared. Remember to include the value of x as x squared because just remember we've linearized the data by adding the x squared, by squaring the value the data in the variable x. So that is our equation. Just look at the multiple choice options. Negative 1.34 plus 0.546 x squared. So therefore B is the correct answer. Question 13. The time in minutes that Liv ran each day was recorded for 9 days. These times are shown in the table below. The time series plot below is generated from this data. Both 3 median smoothing and 5 median smoothing are being considered for this data. Both of these methods result in the same smooth value on day number. So basically we have to determine what day the 3 median smoothing and 5 median smoothing will be the same. So basically just to save time, I've basically done the 3 median smoothing in blue, as you can see here. And I've also done the 5 median smoothing in green. So basically if you do the 3 median and 5 median smoothing for the graph, you will notice that on day 7, you'll get the same smooth value using either the 3 median or 5 median smoothing, as I've shown here. The red and the green and the blue are on the same day at day 7. So therefore, E is the correct answer. If you are struggling with 3 median smoothing or 5 median smoothing, just leave a comment down below and I will try make a video to try explain how to do median smoothing. Question 14. A least squares line is to be fitted to the time series plot shown above. The equation of this least squares line with day as the explanatory variable, so that's the y variable, is closest to. So it's basically referring to this data up here. So basically we know that day is our x variable and time is our y variable. So basically we know that in the question it says day is the explanatory variable, so that's supposed to be x, sorry. And then we'll just enter this into our CAS calculator over here. So if you can see over here, I'll go home, and then I go to spreadsheet. And then I basically just enter day as x on the calculator and time as y. And then basically I'll just enter the day number values in x. So I'll say 1, 2, 3, 4, 5, 6, 7, 8. 9. Go back to the top, Control 7. And then time is our y, so we put 22, 40, 28, 51, 19, 60, 33, 37, 46. So then we go back to the top and we go in this box over here and you write menu 4, 1, and you say 4 because we want linear regression, because we want to find the linear regression line. So we enter x into the x list, which represents day number, and we enter y into the y list, which represents time in minutes. Hit enter and you'll get the values of a and b, which is so the day equals, sorry, it should be time equals, because that's our response variable, equals a 28.5 plus 1.76666 times day number. So basically we can instantly get rid of these because we know day number is not the response variable, time is the response variable, day number is actually the explanatory variable. So basically E matches our equation over here, so therefore E is the correct answer. Question 15. The time series plot below shows the monthly rainfall at a weather station in millimeters for each month in 2017. The median monthly rainfall for 2017 was closest to. So basically we've got to work out the median monthly rainfall for 2017. We know that there's 12 months, so we use the median formula over here, which is n plus 1 on 2. We know that the value of n is 12 because there are 12 months in the year of 2017, or in each year. And if you do that, that gives you 6.5. So you got to calculate 6.5 dots from the bottom, and that would help if you use a ruler like this to calculate it, to find where 6.5 is for your median monthly rainfall. So if we do that, we count 1 dot here, 2, 3, 4, 5, 6 dot is over here, and the 7th dot is over here. So if you highlight the 6th dot over here and the 7th dot over here, we know that our median is 6.5, so it must be in between there. So if we look at the median monthly rainfall over here, we see that we know that this point over here is 110. So therefore, our median appears to be around 105 millimeters. So just let's look at the multiple choice options. We see here that D is 103 millimeters, which is very close to what we have over here. We're just assuming that this is around 105 millimeters. We have an option that says 103 millimeters, so therefore D is the closest answer, and therefore D is correct. Question 16. If 7 mean smoothing is used to smooth the time series plot, the number of smooth data points would be. So the way I'll do this question is basically just try calculate which point from a month would be my 7 mean smooth value from each end to find the number of smooth points. So basically this is what I'd do. I'd count 7 from this end, so 1, 2, 3, 4, 5, 6, 7. So the 4th point would be our middle point, 1, 2, 3, 4. So this is the first point that would be used. That would have a 7 mean smoothing. So therefore, just count from the other end to find which would be the last point that would have a 7 mean smoothing. So you count 1, 2, 3, 4, 5, 6, 7. So the middle point would be 4 from the end. 1, 2, 3, 4. So therefore, this would be the last point that has 7 mean smoothing. So to find the number of smooth data points, if we were to use the 7 mean smoothing for this time series plot, you just count from this line over here to this line over here. So just 1, 2, 3, 4, 5, 6. So therefore C is the correct answer.